Good morning, boys and girls. Today we're doing 11.7, solving problems with Pythagorean Theorem. Homework's page 511, 1 through 19 odd. I want you to try some of the B problems, especially 29. If you can't do it, it won't be counted against you. Just make sure you do 1 through 19. Vocabulary for today is hypotenuse and the legs of a right triangle. All right, so this theorem works for right triangles only, not just any old triangle. A right triangle has three parts. Two sides that are called the legs, and they are surrounding that, they are adjacent to that little right angle there. And then opposite the right angle is called the hypotenuse. Everybody say that. Hypotenuse. Hypotenuse. Okay? So it's always opposite the right angle. That's the big one to remember. It's generally the longest side, and it is always opposite the right angle. So the way the theorem, a lot of times we call one leg A and the other leg B, and they're interchangeable. And generally, the hypotenuse is referred to as C. But don't bank on that, because a friend of mine who used to teach calculus said that on one AP exam, they renamed the legs, one of them C. So just make sure you keep it. But for our purposes, for our class, we're going to name it A, B, and C. So the way this works is the legs are interchangeable. You can call one leg A, the other B, or the other leg A and the other leg B. But the hypotenuse always has to be C. It's always opposite the right angle. And the way the Pythagorean theorem works is a squared plus b squared equals c squared. So let's try it. We always start out with a formula. When given a formula, that's what we do as algebra students, so I expect you to start with it every time. And so now I'm going to take my 6 and I'm going to square it. I'm going to take my 8 and I'm going to take my 6, I'm going to square it under the A. I'm going to substitute. Okay, I'm going to take the 8 because it's a leg and substitute it for B, and then I'm going to substitute X for C. And then I cannot add the 6 and 8 first. I have to square before I add the bases. Okay, we have to simplify that. We do exponents before adding. So 36 plus 64, when we add that up. Now, we're going to root both sides, okay? We're using our inverse operations to get x alone. We root both sides. I take the square root of 100 and the square root of x squared. Now remember, when we take the square root of x squared, we get the absolute value of x, right? To lose the absolute value, we set the 10 to the positive or negative. But remember, with distance, since this is a distance measurement, that's the goal of Pythagorean theorem, to find the distance of this line. So since distance, this is distance, the negative value will not be used. So I do expect you to show your work like such. Okay? All right. You want me to pause it? Okay, now, if you need to pause it, pause it. Let's try one, and you guys try it on your own. Go. Okay, let's check our work. We've got 7 squared plus 4 squared equals y squared. I add them up, and we have 65. It's not a perfect square. For tonight's homework, I would like for you guys to give me the answers. Well, it looks like they're estimating or reduced. No, let's do reduced radical. Let's switch it up. Let's do a little bit of each. I want you to, some of them, they're giving you answers for both. So they're giving you estimated and reduced radicals. Let's do both. Okay, you're only potentially doing 10 problems, so I want you to estimate the answer and reduce the radicals. So we're going to take the square root of 65, and we get the absolute value of y, so 60 plus or minus 65, but 65, negative 65, it can't be. So I would like to see both of these answers right here, okay? I want you to estimate to both. I want the reduced radical and estimated to the nearest tenth, which, by the way, that was a quiz question. All right, let's try the next one. This one's a little bit different. Can you guess why? That's right. I knew you were thinking that. They gave us the hypotenuse, okay? So this time I'm substituting in 15 for the c, and then we're going to just solve it like a regular. T squared plus 36 equals 225. I have to solve it like a regular equation. Subtract 36. I get t squared equals 189. Take the root of t squared. Okay, now 189... 1 plus 8 is 9, and 9 is 18. So that is divisible by 9. So I know there's at least it's divisible. So 189 divided by 9 is, 189 divided by 9 is 21. So 9 and 21. So if I'm estimating that, that comes to 9 and 21. So that would be 3 rad 21. Or if I'm going to estimate it, we know it's more than 13, less than 14. It's closer to 14. So I'm going to say like 13.7. Let me try my second. 13.7, I guessed it right. Now, I personally think that it's easier to estimate from here versus here. You're going to end up, it's just, I don't tend to be as accurate. I just can't see that distance between 13 and 14 much clearer when I'm at 189 than if I'm doing the square root of 21. So, and when I'm saying t is about equal to 13.7, but when I'm using the radical, okay, I really should be using an equal sign. Let's see how they wrote it here. Okay. Same thing. All right. Now, we can determine if it's a right triangle by using our Pythagorean theorem. If this works out to be equivalent, if I substitute these numbers into the right triangle, into the Pythagorean theorem, and both sides are equivalent, then that means it's a right triangle. If both sides are not equivalent, then it's not. So, for instance, if I do a squared plus b squared equals c squared, I'm substituting 5 squared plus 12 squared should equal 13. 25 plus 144 equals 169. When I add 25 and 44, I get 169. So this is a right triangle. Let's try the next one. You guys try it on your own. Now let's check. Now, when you're doing this, remember, when you've got a squared plus b squared equals c squared, I've got, what you have to remember is the biggest side always goes in for the c. So if you just did it in the order they gave it to you, you probably would have gotten this wrong. So 9 squared plus 6 squared equals 12 squared. A and B are interchangeable. 81 and 36, 6 and 1 is 7, so that doesn't, they're not. So this is not a right triangle. Not a right triangle. Okay? Okay, Pythagorean triples. There are certain numbers, and you'll start to recognize them, like 3, 4, 5 is a Pythagorean triple. Now, if I double that, I'll get 6, 8, and 10. That, too, is a Pythagorean triple. If I triple 3, 4, 5, I get 9, 12, 25. If I quadruple it times 4, these are all Pythagorean triples, and so on. If I take that initial group and multiply it by 2, I get this. Multiply it by 3, multiply it by 4, multiply. I'll keep going and get a right triangle. Okay, another Pythagorean triple would be 5, 12, and 13. So if I double it, triple it, quadruple it. And another one would be 7, 24, and 25. You see these all the time. I'll show you the ones. I'm going to highlight the ones that come up all the time. You see these all the time. Okay. All right. Here's an example of a proof, okay? So let's say we start with a square, and we make a square within that square, okay? So if I go from 3, the third dot, to the fourth dot, and then the third dot, to the third dot, then I go to the third dot, and then I go to the third dot on the next line. Okay, that gives us a square. Now, if we cut all those edges off, okay, let's just look at that. We'll label that A, and that will be B. So in every triangle, I can name that A, B, and C. So the small side will be A, the longer side will be B, and the longest side will be C. Small side A, bigger side B, and so on. Okay? And we will call that inside part, we'll make that yellow. So really we can call that C squared because you will see this is C times this is C, so we get C squared. Okay? So if I pull out those purple corners, right? Okay, I can make my own little rectangles with them, right? Line up the C's, I can make my own little rectangles. Now I should be able, what you can see is that I can put these back in, right? I'm going to put the other one back in. And now what we have is, remember we said that big yellow area equals, the whole area except for the purple was C squared. And then we made it yellow, right? We said that whole area except for, let me go back. We said the whole area except for the purple is C squared, right? So if I put these back in, these purple parts back in as rectangles, is it still not safe to say that the whole area outside of the purple is still that yellow area? And we called those two areas, when you add it together, it was C squared. So now what we can do is call these, when you put them together, they're C squared. But let's look at these extra little pieces. Since this is A and this is A, that would be A squared. Since this is B and this is a measurement of B, this is B squared. And didn't we say that this entire area that's not purple is equivalent to C squared? So A squared plus B squared equals C squared. And that, my friends, is your first proof. Right? Okay, we have proven Pythagorean theorem. Here's another one. We can take the total area, A plus B, times A plus B. So the quantity of A plus B times the quantity of A plus B. And we can substitute out the purple area and we'll get the yellow area. So if we do the whole area, it's A plus B squared. The purple area is 1/2 A times B. 1/2 A times B times 4, right? The area of a triangle is 1/2 the height times the base, so it's 1/2 the height times the base times 4, and it should equal the yellow area, which is C squared. So if I now multiply that out, FOIL it, we get A squared plus 2AB plus B squared. And then I'll end up with minus 2AB. Minus 2AB, right? Because those will cross cancel, equals C squared. And then what we get is A squared plus B squared equals C squared. So that's theorem number 2. All right, so that is the Pythagorean theorem. Now I'm going to do another mini video on the distance formula, but I'll stop the video now.